Okay, so like I said on percent increase or decrease, when you do a percent increase, you're going to do R equals 1 plus your percent. And when you do a percent decrease, that would be R equals 1 minus your percent. All percents need to be written in decimal form. You can do that by taking any percent and dividing by 100, because that's literally what percent means. Percent means a number out of 100. So for example, a 6% increase. Increase means we're going to be adding 1 plus the percent. So we got to take 6%, change that to a decimal. Decimal form is 0.06. And again, if you don't know where that comes from, whoops, you can grab a calculator and divide. So 6 divided by 100 is whoops, I don't want it in fraction form. Let's put it in decimal form. Is 0.06. So you take 0.06, add it to 1, and we get our multiplier of 1.06. Okay. A 27.3% decrease. We are going to take our 1 minus our percentage. 27.3%, I should say, is 0.273. So we grab our calculator. 1 minus 0.273 is 0.727. Okay, so what that means is if you want to decrease something by 27.3%, you multiply it by 0.727. If you take a number and you multiply it by 0.727, you have decreased that number by 27.3%. So that's what we mean by multipliers. So you multiply any number by these things to create a 6% increase or a 27.3% decrease. A 1.25% increase. Increase, again, is we add to 1, change that to a decimal, and that'll be 0.0125. So we add 1.0125. 7.2% decrease. 7.2% is 0.072. So 1 minus 0.072 is 0.928. So again, if you multiply a number by 0.928, you will be doing a 7.2% decrease. Yeah. There, let me just open it really quick. Okay, go ahead. Okay, so where is something that this might be useful to you? If you need to calculate something like sales tax, a 6% increase could represent a 6% sales tax. I think sales tax in Placer County is like 8.25. But anyway, that's how the sales tax is calculated when you purchase something. You multiply by 1.0825, and that will calculate your price, including sales tax. Let's say you go out to dinner and you want to leave a tip. Let's say you want to leave an 18% tip. That means you need to increase the amount of your bill by 18%. So let's say you go out with a group of friends and you spent, $12 on your meal. Multiply that by 1.18. That will tell you what you owe, including tip. And then you can Venmo that amount to your friend. So if you guys are all going out to dinner together, one person might end up paying the bill and you guys Venmo your share. That's how you can calculate what you would include with the tip. Without the 1, this is the tip by itself. 0.18 is just the tip. The 1 in there, it makes it your amount including tip. So the 1.18 is your full amount including tip. Without the 1, it's just the tip by itself. Okay? So that's just an example of where you might want to calculate a percent increase or decrease. And since you guys have your phones with you pretty much all the time, as do I, you have a calculator with you at all times. Okay, Mrs. Stadler, I'm going to invest $1,000. Lucky me, I have $1,000 to invest. And my investment is going to pay me 9.7% interest. That means I am going to get 9.7% increase. That's what paying interest means. So I am going to earn a 9.7% increase on my money. So that would be R equals 1 plus 0.097. That's 9.7% as a decimal. My R value is 1.097. And now I'm going to put my money into the account, into the investment. I'm not going to touch it for 15 years. And I want to figure out how much I'm going to have. If I take 1,000 and I multiply by 1.097, that will tell me how much money I have after 1 year. That'll be the amount of money in the investment account at the end of 1 year. If I multiply again by 1.097, that's how much I'll have at the end of 2 years. If I do it again, that'll be 3 years. If I do it again, that'll be 4 years. So this basically turns into a geometric sequence because we are multiplying. We know that the explicit formula for a geometric sequence is that a sub 1 times r raised to the n minus 1 power. And we've said that as long as this subscript matches the number you're subtracting, any formula is fine. So in other words, I could put the second year here, but then I would do n minus 2. So if that is the case, I could do this. I could put a sub 0 in the front, r, and then here I would have n minus 0. Either one of these formulas will work. The advantage to this one here has to do with the 1,000. The $1,000 that's in my account is a sub 0. This value right here is how much I have at the very beginning, not after 1 year. That's how much I have, right now, and I haven't earned any money on it yet. I haven't earned any interest. That's my initial value. That's my a sub 0. So one advantage of using this formula is I can just use this value in my formula. So I can figure out that a sub 15, so my amount in 15 years is 1,000. R is 1.097. And then the exponent says n minus 0. 15 is my n, minus 0 is 15. So I could do that. Whoops, give me my calculator here. Put it over here. So I could do 1,000, 1,000 times 1.097 and raise that to the 15th power. And that'll tell me at the end of 15 years, I'm going to round to 2 decimal places because this is money. So I'm going to have $4,009.58. So not bad. I've got more than 4 times the amount I started with. And it was just sitting there. Of course, it was 15 years, but again, it was just sitting there. Okay. Now, if you want to use this formula instead with the a sub 1, there's nothing wrong with this. However, you would first have to calculate a sub 1. We don't have a sub 1. We have $1,000, which is a sub 0. That's the amount of money before the sequence has started. The sequence is the interest payments. So if you're going to use the formula right here that I've boxed in pink, you would have to figure out a sub 1, which is 1,000 times 1.097, which is 1,097. So in other words, at the end of the first year, you now have 1,097. You earned $97. Now you can do it. So now you can do a sub 15 equals 1,097, 1.097, and then n minus 1, you would use the 14th power. That will work. You'll get the exact same answer. So it does not matter how you do it. This one, the one advantage is you don't have to calculate a sub 1 because you just use a sub 0. But there's nothing wrong with doing it this way. Calculate how much is in your account after 1 year, and then you got 14 more years to go. If you start with a sub 0, we haven't done any interest yet, so we have 15 years to go, which is why the exponent is 15. So the exponent is how many more times do you get paid the interest. I get paid interest in 15 years, 15 times total. So if I start here, I haven't earned any interest yet, so I still have to get paid 15 times. Here, I got paid once, so 14 more times. So it does not matter how you set up the formula as long as the exponent matches what you've put in the front. So if you put year 1 here, 14 more years in the exponent. If you put year 0 here, 15 years in the exponent. Okay, so today we are going to finish our notes on sequences. So we're going to look at our last section in sequences. So I'll let you guys pull up chapter 4 notes, page 11. There's a lot of notes this chapter. So as always that we've been doing in this chapter, I'll have you guys turn this in at the end of class, or at least by the end of the day. And so far so good. My iPad has stayed connected, so far so good. Okay. So what we are looking at today, if you look at the agenda, you'll see that we're going to be doing notes on what is a recursive formula. Okay. The word recursive means going backwards. So a recursive formula for a sequence is a formula that is based on going back to the previous term. So when you do something recursively, you're doing something, backwards, or you're doing something going back into the past. So in a recursive formula, if I want to find the 4 here, I got to do something to the 8. If I want to find the 8, I got to do something to the 12. If I want to find the 12, I got to do something to the 16. So a recursive formula is all about figuring out what do you do to a term in your sequence in order to get to the next one. Okay. So if we take a look at this sequence here, 16, 12, 8, 4, what's going on? In other words, what do we do to the 16 to get the 12? We're subtracting 4. And if that pattern continues, that'll also tell us what kind of sequence this is. So from 12 to 8, we also subtract 4. From 8 to 4, we also subtract 4. So we have a consistent pattern here. This sequence is being generated by subtracting 4 from the previous term. Okay. So in other words, if I want to find the 10th term, I take the 9th term and I subtract 4. If I want to find the 193rd term, I take the 192nd term and I subtract 4. So that's what recursive tells us. Recursive tells us that we just take the previous term and we do whatever it says. In this case, subtract 4. Now this does make it arithmetic. Okay. We know that when you add or subtract the same number every time, you have an arithmetic sequence. When you multiply by the same number every time, you have a geometric sequence. If neither of those apply, then you just have some other type of sequence that might not have a specific name. Okay, now since it is arithmetic, I could create an explicit formula for the sequence. Explicit means a formula where all you do is you plug in values of n and you can find any term you want. So we know how to do this. We know that the explicit formula is you take the first term and then you add your common difference. My common difference is -4, parentheses, n minus 1. So this is the explicit formula that we did before. So this is not new. So in other words, if I take this sequence and I say, I want to find the 100th term, you put 100 in there and you get 99. And then you do 16 minus 4 times 99. Okay. So you can use an explicit formula to find any value n. Okay. So any term. Okay. A recursive formula is a little different. So first off, notation. A sub n. We already seen this. This is the nth term. So a sub n just refers to the nth term. A sub n minus 1. Well, that's one term less than that. So this is the term before the nth term. So this is the term previous to the nth term. So this is the term previous to the nth term. Okay. So in other words, if I say I want n to be 15, then a sub n would be a sub 15, which is the 15th term. So if I say, let's let n equal 15, then a sub n would be 15th term. A sub n minus 1, 15 minus 1 is 14. This would be the 14th term. So a sub n minus 1 is just a fancy way of saying the previous term. If I'm trying to find the 15th term, a sub n minus 1, this whole thing just means 14th term. If I'm trying to find the 5th term, this right here would just be 4th term. So this is just a notation here of the previous term. We're not multiplying anything there. We're not doing anything with that. That is just the notation to mean the previous term to the one that we're dealing with. If we're dealing with the 5th term, that highlighted one is the 4th term. If I'm trying to figure out the 15th term, that highlighted term there is the 14th term. It's just a way for us to say the previous term. So a recursive formula involves giving the first term and the nth term in terms of the previous term. In other words, you say what to do to the previous term. So an arithmetic recursive formula has two pieces. The first thing you have to do is give the first term of the sequence. So you write down a sub 1 is whatever. And then you say, how do we generate this sequence? I find the nth term by taking the previous term and adding my common difference. If it's arithmetic, that's how we generate it. How do I find the 5th term? I take the 4th term and I add the common difference. How do I find the 10th term? I take the 9th term and I add the common difference. How do I find the 25th term? I take the 24th term and I add the common difference. So that's all this is saying. A sub 1 is giving a starting place. Here's my first term. The second part of the formula, because it is two pieces, the second part of the formula tells you what to do next. So you tell somebody with a recursive formula where to start, and then what do we do next? If it's geometric, same thing. You got to give the first term. So you write down what the first term is. And then you say, what do we do next? And if it's geometric, what we do next is we multiply by our common ratio. So we take R and we multiply that by the previous term. So if I want to find the fifth term here, I take my fourth term and I multiply by R. If I want to find the 10th term, I take the 9th term and I multiply by R. So again, this thing that A sub n minus 1, we don't do anything with that. That just means the previous term. So write a recursive formula for our sequence above. Remember our 16, 12, 8, 4? That was arithmetic. So I can write an arithmetic recursive formula. So we had 16, 12, 8, 4. That's my sequence. Let's write a recursive formula. It's arithmetic. So the first thing we do is we write down the first term, which is 16. So that's the first thing you do. Tell me what the first term is. And then you tell me, what do we do next? Okay, so now to get the next term, I'm going to take my previous term. So if I want to get 12, I take this. And what do? We add our common difference. Our common difference was -4. This is a subtract 4 arithmetic sequence. So I know that all this is saying, this sequence starts with the first term of 16, and then you find the next term by taking the term you have and subtracting 4. So I find my second term by taking my first term and subtracting 4. I find my third term by taking my second term and subtracting 4, etc. So if I asked you now to find A sub 5, so if I said, hey, use this formula here to find A sub 5, it means I'm going to put a 5 right here. So I'm going to say A sub 5 equals 5 minus 1, n minus 1, 5 minus 1 is 4. So that equals A sub 4, take away 4. And then I go back to my sequence and I'm like, oh, wait a minute. There's A sub 4 right there. Okay, that's A sub 4. So I'm going to take A sub 4, which is 4, and I'm going to subtract 4. So how do I find A sub 5? I take my fourth term and I subtract 4. So I know that my fifth term is 0. Okay? And I'm sure you could have told me that without writing all of that down, but that's how the formula works. It's literally telling you, what do we do to the term that we have, 4, to get the next one. So I've got 16, 12, 8, 4. What do I do next? I keep subtracting 4. So this just tells you what you keep doing. Okay, so here's another example. 12, -3, +3/4, -3/8. What kind of sequence is this? So is it arithmetic or geometric? It's geometric. Okay. Okay. This is geometric. If I ever ask you to look at a sequence, tell me what kind it is, it's going to be one of those two. Because any other type of sequence, it's not that easy to tell by looking. You can tell by looking if a sequence is arithmetic or geometric. In this case, take a look right here. I can take 12, I can multiply by something to get -3. Specifically, I take -3, divide by 12, and I know that my common ratio is -1/4. If you don't like fractions, you can write -0.25. Okay, that's my common ratio. So I take 12, I multiply by -1/4, and I get -3. And then you multiply by -1/4. Negative times a negative is a +3/4. And then you multiply by -1/4 again. So you'll notice that this sequence alternates positive, negative, positive, negative. And that's because when you multiply by a negative, you change the sign. Okay, we're going to write a recursive formula for this sequence. It's geometric, and right here is the geometric recursive formula. It requires two things. You got to tell me the first term, and then you got to tell me what to do next. So my first term, a sub 1, is 12. Well, what do we do next? Okay, I take r and I multiply by the previous term. R is negative 1/4, and I multiply that by a sub n minus 1. That's the formula. This is a multiplication dot here. Okay. So how do I find the second term? I take the first term and I multiply by negative 1/4. That'll give me the second term. How do I find the third term? I take the second term and I multiply by negative 1/4. How do I find the, whatever term that I want? So if I wanted to find the fifth term again, I put a 5 here and I say my fifth term is equal to negative 1/4 multiplied by, this is 5 minus 1. This is my fourth term. My fourth term is negative 3/8. So I am going to take negative 1/4 and multiply by negative 3/8. And remember that when you multiply fractions, you can go straight across. So this is going to be positive 3 over 32. 4 times 8 is 32. So positive 3 over 32 is my fifth term, because I take my fourth term, the negative 3/8, and I multiply by negative 1/4. Okay. Now, downside of recursive sequences. Okay. Suppose for this sequence here, I asked you to find the 20th term. Is doing it this way quick? No, because to find the 20th term, I'd first have to find the 19th term. To find the 19th term, I'd first have to find the 18th term, and then the 17th term would be needed for that, and the 16th term would be needed. And so basically, I would have to create the entire sequence, starting with term 1, and I'd have to go all the way out to term 20. So no, this is not a very practical way to find a specific term that's far away. Fifth term, fourth term, sure, not so bad. But 20th term, 100th term, no way would you want to use a recursive formula. It would be much easier to use an explicit formula. An explicit formula, you just plug in your n here and you're done. Like if I wanted to find the 100th term of this, super easy. I just put 100 in there and I'm done. I would not want to use this recursive formula here, because I would have to do this recursive formula 100 times. I would not want to do that. So some people ask, well, then what is the use of a recursive formula? So it does have its downside, and specifically for arithmetic and geometric, the fact that we do have explicit formulas probably does make it that people don't use recursive formulas for arithmetic and geometric very often. Like, for example, right here, a sequence has the following recursive formula. Here's a recursive formula. You might recognize what type of sequence this is. And if you do, you don't even have to use the formula. You can tell me what the first 4 terms are. So first term is negative 14. It says so right there. Second term, I take the first term and I add 2.5. So my second term is going to be the first term plus 2.5. If I take negative 14 and add 2.5, what do we get? Okay. Right, because we subtract or we add 2 to that, that'll give us negative 12, and then we have to add the other 0.5. And since it's opposite signs. Okay, well, there's my second term. My third term You take the second term and you add 2.5. So add 2.5 to that. Okay. If you add 2, you'll get to negative 9.5, and then add the 0.5. So we're at negative. Hey, wait a minute. Yeah. Okay, fourth term. We take the third term. And we add 2.5 again. By the way, most people wouldn't write this all out. They would just write the sequence out. So if I add another 2.5, if I add 2 to that, I get negative 7. If I add a positive 0.5 to that, I get negative 6.5. And we're almost there. Oh, nope, it said first 4 terms, didn't it? So we're done. So my first 4 terms are negative 14, comma, negative 11.5, negative 9, negative 6.5. Now, you probably could have done this by just looking at this and realizing, okay, I got to start at negative 14. This is arithmetic. What do I do after I start with negative 14? I just keep adding 2.5. So you don't have to write all this down. I start at negative 14. What do I do next? I add 2.5. What do I do next? I add 2.5. What do I do next? I add 2.5. So the 2 pieces here are important. You've got to know where to start. If you don't know where to start, you can't do anything. So you got to know where to start, and then you got to know what to do next. So the first part of the recursive tells you where to start. The second part of the recursive tells you what to do next. And again, I realize that recursive formulas are a little time consuming. But here's the beauty of a recursive formula. We're going to create a sequence here that is not arithmetic, nor is it geometric. So a sub 1 is 3. That's my first term. This says to get to my next term, I'm going to multiply the previous term by 3, and I'm going to add 2. So my second term is going to be 3 times the first term plus 2. Okay? Because you put a 2 in there, that becomes a sub 1. So you take a sub 1, you multiply by 3, 9. Add 2 to that, 11. There's my second term. My third term, 3 times a sub 2 plus 2. I'm going to take that, multiply it by 3. That's 33. Add 2 is 35. This is not arithmetic. It is not geometric. A sub 4. I'm going to take a sub 3, multiply by 3, and add 2. So 35 times 3, I'm going to start using a calculator now. Come on. 3 times 35. Oops. 3 times 35 plus 2. 107. Oops. And then my last, because it's asking for the 5th term. So here's my 5th term. I find that by taking 3 times the 4th term and add 2. So I've got 107. 3 times 107 plus 2 is 323. So I found my 5th term. This sequence looks like this: 3, comma, 11, comma, 35, comma, 107, comma, 323, and then it continues. That's just the first 5 terms. Okay. Now, if I gave you that sequence, it is not arithmetic, it is not geometric. I bet it would be very difficult, if not almost impossible, for anybody to look at that sequence and say, oh yeah, I see exactly what's going on. This tells me what's going on though. So this recursive formula helps me see what's going on in this sequence because it is not obvious. What's going on? You multiply by 3 and add 2. How do I get the next one? I multiply by 3 and add 2. How do I keep going? I multiply by 3 and add 2. How do I keep going? I multiply by 3 and add 2. That's where a recursive formula has its beauty right here. We would not be able to figure out an explicit formula for this. First of all, it's not arithmetic, it's not geometric. And I would imagine that the average human person looking at this would not even be able to see the pattern. There is a pattern here, but it is not obvious. It is not obvious that, oh, it's a multiply by 3, add 2 pattern. As soon as we start combining stuff like that, like multiplying and adding together, it becomes nearly impossible for us to recognize that as a pattern. So that is where a recursive formula really comes in handy. Without the ability to do this, we would not be able to see the pattern here. Okay, so that's what a recursive formula is. It tells you where to start, 3, and then it tells you what do we do next. Multiply by 3 and add 2. Now this a(n sub 1) does not mean anything of itself. It just means the previous term. So that second part of the recursive, so this part right here, is just telling you, what do I do next? I start with 3 right here. That's my first term. What do I do next? I take my previous term. I multiply by 3. I add 2. That gets me my second term. Then what do? I do it again. I multiply by 3, add 2, multiply by 3, add 2. Okay. So on your Delta math tonight, you are going to be seeing some recursive formulas. So some where they give you a sequence that's arithmetic or geometric. They're not going to give you something like this and ask you to write the recursive formula because, like I said, it would be almost impossible for anybody in here to actually see what's going on here. But if it is arithmetic or geometric, you should see the pattern. You should be able to write a recursive formula. So there's a part on Delta Math that's going to have you write arithmetic and geometric recursive formulas, and that's generally how they go. Arithmetic, you're adding the same number every time. Geometric, you're multiplying by the same number every time, okay? And then there are some problems where they give you a recursive formula like this. It may not be arithmetic or geometric. It may be like a combination thing like this. And they ask you to find, the 4th term or the 5th term. And you're basically going to do this. You're going to start where it says, and you're going to do what it says and go as far as you need to figure out the 4th or the 5th term. And then there is a part on Delta Math where you're doing percent multipliers like we did on the warm-up. How do you show a 5% increase? How do you show a 24% decrease? Okay, so just like we did it on the warm-up, what do you multiply by in order to increase or decrease by a percent? Okay, so that's where we are there. I'm going to